Hello everyone. In this video, I will explain how the 7 segments work on the Artix-7 FPGA. I will show you how to use the 7 segment IP from the project files. I will show the Verilog code used to create the 7 segment IP. And lastly, I will demonstrate a real-time example of the 7 segments being used to display numbers of our choice. On the Artix-7 FPGA, each individual 7 segment can be treated as having two main input sources. The first is the cathode bus, which is comprised of A, B, C, D, E, F, G, and DP. The cathode bus is what determines which LEDs are on and which ones are off. To make an LED be turned on, we simply set its corresponding cathode low. This means that to make the number 2 appear, we would need to set cathodes A, B, D, E, and G to 0, while keeping the other ones high. The other important input is the enable input. The enable input comes from an anode bus, which consists of 8 signals. When the enable signal is 0, the digit is enabled, allowing the cathode bus to determine which LEDs turn on. When the enable signal is 1, all of the LEDs are turned off, regardless of what is happening on the cathode bus. On the Artix-7 FPGA, all 8 7-segment displays share the same cathode bus, but receive their own enable signal from the anode bus. That means if we set the cathode bus to make a 2 and set all enables to 0, then every single display will show a 2. The question now is, how do we display numbers like 792? The answer is that we need to update each display one at a time. First, we set the cathode and anode buses so that only display 0 shows a 2. Next, we change the bus values so that only display 1 shows a 9. Then, we change them again so that only display 2 shows a 7. The remaining displays stay off during their respective intervals. This entire process is repeated continuously. When the intervals are slow, we can clearly see that only one display is on at a time. However, when we reduce each interval to around 1 millisecond, the displays alternate so quickly that our eyes perceive all 3 digits as being on at the same time. This creates the appearance of the number 792. The 7-segment IP block from the project files allows you to display any number by driving the following 4 inputs. The outputs are driven automatically. This IP block allows you to drive the 7 segments very easily without having to worry about the lower level details. The digits input allows you to control what is displayed on each digit. For example, to make the 7 segments display 0, 1, 7, 3, 8, 8, 0, 1, we must use the following assign statement in Verilog. The decimal point input allows you to control which displays show a decimal point. Because the decimal point signals are active high, a 1 turns a decimal point on while a 0 turns it off. For example, to turn on the decimal points for displays 7 and 3, use the following assign statement in Verilog. The negative sign input allows you to control which displays show a negative sign. Because the negative sign signals are active high, a 1 displays a negative sign while a 0 displays the assigned digit. For example, to display negative signs on displays 5 and 0, use the following assign statement in Verilog. The active displays input allows you to control which displays are enabled. Because the display control signals are active high, a 1 enables the corresponding display while a 0 keeps it turned off. For example, to enable only displays 6, 3, and 1, use the following assign statement in Verilog. So as an example, let's think about how we can use the IP block to display 0, 2, 2, 5, 7, 7, 3, 3 on the 7 segments. I recommend pausing the video and seeing if you can figure out how the 4 inputs of the IP block need to be driven. Alright, so this is how we would need to drive the 4 inputs. Here is another example. Again, I recommend pausing the video and seeing if you can determine how the 4 inputs need to be driven yourself. Alright, so this is how we would need to drive the 4 inputs. Alright, so this here is the Verilog code for the 7-segment IP. To demonstrate how it works, I created a top-level module that instantiates the IP block. Inside the top-level module, we can drive the inputs using the same values from the 2 examples. First, let's generate the bit stream using the signals from example 1. Alright, the bit stream has finished generating. When we program the FPGA, we can clearly see that the 7-segment displays are showing the correct numbers. Now let's try it again using the signals from example 2. Alright, the bitstream has finished generating. When we program the FPGA, we can clearly see that the 7-segment displays are showing the correct value, including the negative sign and decimal point. If you've made it this far into the video, then you should feel confident taking the 7-segment IP from the project files and using it to display any value of your choice. This IP can be very useful for displaying the result of a sensor reading or a calculation, so it is definitely worth using in your own projects. Alright, that's all for this video, and I look forward to seeing you in the next one.